In today's lesson, we're going to spend some more time looking at tables. So not really any new ideas, just we're going to work on these tables and see what things we can figure out based on the patterns that we see or information that we got. So tables are usually a little bit more challenging than graphs because you can't literally see the information. On a graph, you can see where it starts. You can make a triangle and find the rate. Tables are a little bit more challenging sometimes. The first thing you kind of want to do when you look at a table is decide for yourself, is it partial or direct? That we can tell if we can find when the number of is 0. If we can see that, well, then we'll know if it starts at 0 and 0 or 0 and something. And if it's direct, it's going to start 0, 0. If it's partial, it'll start 0 something. Okay. If it's direct, we like those ones because all we need is a rate. Just figure out what is the multiplier between the numbers. So if I saw, I don't know, 1 and 2, well, I just doubled it. Or if I saw 1 and 20, I times it by 20. 1 and 200, I times it by 200. But partial, again, those are the tricky ones. We're going to have to use our formula, rise over run, to figure out the rate. Also, if it's partial, we're going to have to find that initial value if we don't see it in the table. And we can do that by using any 2 points that we can find, and it's kind of what we did before. Okay, so let's take a look at some examples. Julia, she's known for taking long hot showers that leave the rest of her family waiting. They decide to study the amount of water she's using. So she gave us a table here. Is this relationship direct or partial? I can tell pretty quickly by finding when the number of minutes is 0, well, it's 0. That tells me this is direct. There was no initial value. Okay, I want to find the rate. I want to find rate. We do our up and over trick, right? Well, look at this table. It's arranged in a slightly different way this time. So I have to think about where the up and over comes from. The up is always the second thing in the table. That's the difference between any 2 points here. So if I go from 90 to 162, I've gone up 72. And the over is always the first thing in our table. So if I chose these ones, that'd be over 4. 72 watt, this was liters, and 4 minutes. And 72 divided by 4 turns out to be 18 liters per minute. And that's using my triangle trick, just the table form of it. But just to point out, because this is direct, we could have figured this out in a totally different way. If it's direct, everything is always a multiple. 2 times what makes 36? If I can't think of it, let's do the dividing trick. 18. How about 90 and 5? Turns out to be 18. They have to be just a direct multiple of each other if the relationship's direct. As I said, sometimes it's hard to just look at it and see, so if I use my triangle trick, it works too. Right, write an equation, that's kind of our standard thing. Let's see, x would be my number of minutes. That's my first thing in my table. Y was my liters. That's the second thing in the table. We had no initial value, so just the rate, 18 liters every minute. Direct relationship, just as one part. All right, she takes a shower for 15 minutes. How much water she's going to use? Well, that's where we use our equation, right? It's 18 for every minute. Well, if she goes for 15 minutes, send to our calculator, and we should get 270 liters. Done. Okay, kind of our typical question. Nice one because direct, a little bit easier to do. Okay, but that's the kind of things you have to be able to do. Try another one. Table of values below shows Mindy's pay at Vision Optical, where she earns an hourly wage plus a fixed amount. There's some clues right there. Hourly wage, in other words, a rate, plus a fixed amount, in other words, an initial value. So we know right off the bat this is going to be partial, which is what part A is asking us about. Partial, without even looking at the numbers, just reading the question, we know this is a partial one. Okay, determine the fixed amount. In other words, determine the initial value. That's what a fixed amount is, what you start at. So if I find the number of being 0, I found my initial value. Okay, determine her hourly wage. Well, we know how to do rates. Rates, I pick any 2 points in my table, and this one's kind of nice. I went up from 270 to 390, so I went up 120. Over the course of, I went from 10 hours to 20 hours, so that's 20. Units, $120 for 20 hours. In other words, she's getting paid $6 per hour. That's not 20. That would be 10. Sorry, guys. Over 10. Sorry, my fault, right? We went from 10 to 20. That's up 10. $12 an hour. That seems like an awful small amount. Okay, part D, write our equation. Yeah, this part is hopefully getting pretty good at this now. X equals her number of hours. Y will equal her wages or her earnings. Her initial value we said was 150, and it went up $12 for every hour she worked. How much does she earn after 40 hours? And we're going to use our equation. What's 40? X is 40, her number of hours. So 150 plus 12 times 40. I'm going to do bed math here. Multiply first, add them together. She's going to earn 630 bucks. Okay. F, how long would she need to work in order to earn 450? Okay, what's 450? Her earnings, which we said was her Y value. So if I take my equation, this time I'm going to have 450 equals, that's my Y, 150 plus 12x. Well, I have to solve this one, right? Numbers on one side, letters on the other. So I got 300 equals 12x. We don't want 12 x's, we want just x. So 300 divided by 12 comes out to 25 hours. Okay, so once again, that's sort of our typical question, just the partial version. Now we're going to try the tricky one. This is the last one. Kind of like it's probably as hard as it's going to get, but stuff we can actually do. We just have to think a little bit more on this one. And bowling alley has a fixed base cost and charges a per game rate. Well, it's got two parts. We know it's going to be partial, right? It costs $20.50 for 5 games and $28.50 for 9 games. Write this information in table form. Okay. Number of. What are we talking about here? We're talking about the number of games. And depending on how many games you play, it's going to have different costs. So what do we know? We know 5 games cost $20.50. And we know 9 games cost $28.50. So we've got a table of information. B, partial or direct. Well, the clues were in the question. It was made up of 2 parts, so we know it's partial. It has a fixed base cost. That's our giveaway. Okay, part C, the per game cost. Well, that's just a rate. We know how to do rates. Any 2 points in our table. Well, the good news is we have 2 points in our table. So we went up 8. We went over 4. These are $8 for 4 games, which really means it's costing us $2 per game. And now for the tricky part. D. And this is where you have to do a little bit of thinking. The fixed base cost. In other words, I want to know the initial value. We've always said initial values come from when the table is at 0. But I don't have the table being at 0. My first number is at 5. So I have to actually think about this one a little bit. So I can draw the table again. I'm going to cheat. I'm going to leave some spaces. And we know that 5 games cost $20.50. What would 4 games cost? Well, if it costs $2 a game, that means I have to go back $2. So it cost me $18.50. For 3 games, it would cost $16.50. 2 would be $14.50. 1 would be $12.50. And no games costs me 1050. And that's the key point I need right there. That's my initial value. My fixed cost is 1050. And I can write out the entire table every time. It's totally fine, it makes sense. But if I wanted to cheat a little bit and get back right to here without doing all the work, I would take what I know 5 games costs and subtract 5 games worth at $2 a game, just 10, will get me my answer faster. Okay, so you can do the table, write it out, find the pattern, or just think about the pattern and how far you have to go backwards. Yeah, after that, back to the normal stuff. Write an equation. Okay, X is our number of games. Y is our cost. Y equals our initial value. We just figured it was 1050 plus. It was $2 for every game. No tricks there. And the last piece, how much would it cost to play 12 games? Well, we have an equation. 12 games represents our X value, number of games. So we can take 1050 plus 2 times 12. Bad math. Multiply first and add them together. And it would cost us $34.50. Okay, there's tables. Okay, tables are not bad if you have the initial value. It's when you don't and you have to think about it a little bit. That can be a little bit trickier. So try today's sheet, work with tables, and then we're going to take a little pause and do some practice with some stuff for the next couple of days.